So today we're going to still be solving rational equations, just like today in class and in yesterday's notes. The only thing that we're adding into this is now some negative exponents, which is very similar to what we did when we simplified. So we started with regular rational expressions. Now we're going to see about how we change things when we add in negative exponents. And it really doesn't change things too much. It really just adds a rewriting step that we want to consider. So today's are very short. It's only 3 examples to get you kind of started, and then your assignment will be on Monday. So this first one is going to be similar to what we did yesterday. So we're going to solve 14 over x minus 6 equals 1/2 plus 6 over x minus 8. So we have our fractions. We have 2 being added on the right and 1 on the left. So this means I'm going to find my LCD and solve it similar to how we did yesterday and how we did our complex fractions in Unit 1. So in looking at my denominators, I'm going to make sure they're all factored so that I can get my common denominator. Since these already are, I'm going to take one of each, so the 2, the x minus 6, and the x minus 8. All of those multiplied together will be my least common denominator. So then I'm going to multiply each fraction. So each of these fractions get multiplied by the entire common denominator. So 2x minus 6, x minus 8, 2x minus 6, x minus 8. Okay. So that will be our, after we've factored and found our common denominator, we multiply that common denominator to each term. Then we go and simplify. So on the bottom here, I have the entire x minus 6 will cancel the entire x minus 6. Which means on top I still have the 14, and I'm multiplying it by 2 as well as the x minus 8 that didn't cancel out. On the next fraction, the 2's will cancel. I don't need to write the 1, but I do need to write the x minus 6 times x minus 8 that are getting multiplied to that 1. And then lastly, I can cancel the entire x minus 8. And I have the 6 times the 2 times the x minus 6. So now we've gotten rid of the denominators, and we can go ahead and combine like terms. So before I can combine like terms, I do need to do some multiplying out. So 14 times 2, that's 28. So I'm going to be doing 28 times x minus 8. So when I do that, I'll get 28x minus 224 equals, these two I'm going to FOIL out, and I'll get x squared minus 14x plus 48. I'm going to multiply these two together to get 12, and then I'm going to distribute the 12 to the x minus 6. So plus 12x minus 72. Okay, so I've got everything multiplied out, and now I'm going to combine like terms on each side. So on the left, there's no like terms to combine, so I'm just going to copy that down. On the right, let's see, I have an x squared. If I do negative 14x plus 12x, I'll get negative 2x. And then 48 minus 72 will give me negative 24. So now I've got it into a spot where I can start thinking about solving for x. So when I start thinking about solving for x, I need to get everything onto one side of my equation. So I'm going to bring everything to the side where my x squared is positive. So I'm going to minus 28x and add 224. So I have 0 on the left, and on the right I'll have x squared minus 30x plus 220. No, plus 200. Let's see if I can add right. Okay, so we can solve this using our basic factoring. So double bubble, x times x, and then two numbers that multiply to 200 but add up to 30, negative 30, would be negative 20 and negative 10. So I take each one of those, set it equal to 0, and I get x is equal to 20 as well as 10. So this is all in good, but we have to remember, because there's variables in our denominator, we have to think about restrictions. So we don't want to forget about those. So in our restrictions, we'll have to look at our LCD, or our original denominators, and we're going to set each one equal to 0. Now I don't have to set the 2 equal to 0 because there's no variable there. I just pick the expressions that have the variable. So when I solve, I get 6 and 8. So these are the two values that x can never be, because if we were to get 6 and I plug it back into the original problem, I'd get an undefined fraction. So if we got either of these in our answers, we'd have to cross it off. Fortunately for us, we didn't have that situation, so we can say both answers work. Okay, so this was similar to the ones we did yesterday, a little bit longer of a problem, but we're doing the same problems. There's just going to be a step of rewrite before we get started into this process. So our second example is going to have negative exponents, and we're going to go through how we rewrite that so that we can solve it the same way we did number 1. So number 2, 3x to the negative 2 minus 10x to the negative 1 plus 8 equals 0. So I'm going to start with moving my negative exponents to the denominator of each term. So remember, this is only going with the 3. So when we rewrite it, it's going to be 3 over x squared. Here, that x to the negative 1 will become the denominator of 10, and 8 will just have a denominator of 1. There was no negative exponent there. Once you have it written out like this, you can go ahead and start your solving process, where we look for the LCD. So in this case, our LCD, x squared, if you have the same base, you always take the higher exponent for your LCD. So x squared will be our least common denominator. So we're going to multiply each term by x squared, including the 0 over here. It might seem a little silly, but you want to make sure you do it to every single term, even if it's a constant and even if it's 0. So when we cancel, here the x squared will completely cancel, leaving us with just 3. On the 10, one of the x's will cancel, leaving me with a negative 10x. And then here there was nothing to cancel, so we'd have plus 8x squared. And 0 times x squared will still give us a 0. So now I'm at a point where I have a polynomial that I can double bubble. Now if it helps you to rewrite it in decreasing order, which means we start with x squared, then we do the minus 10x with the 3 at the end, then go ahead and do that. As long as you're keeping negatives with the right numbers, then it shouldn't be an issue. So then I can do my double bubble and think of two numbers that multiply to 8, x squared to go in the first spot, two numbers that multiply to 3 to go in the second spot, to where my outer and inner, when I FOIL it back together, will give me negative 10. So I'm going to start with 4x and 2x, because 4 times 2 is 8. 3, that only has factors of 3 and 1. So if I put the 3 here and the 1 here, I'd have 12 and 2. Well, 12 and 2 is 14. And I am gonna need to make both of these negative because I need to multiply to a positive but add to a negative. So negative 12 and negative 2 wouldn't give me my negative 10. But if let's think about if we put the 3 here and the 1 here. We have negative 4 and negative 6 gives us our negative 10. So now I can go ahead and say 4x minus 3 equals 0 and 2x minus 1 equals 0. So set each factor equal to 0 so we can solve. When we solve, we'll get x equals 3/4, and over here we'll get x equals 1/2. So before we can officially say we're done, we want to check our restrictions. In this case, our denominator that had an x, we had an x squared, and we had an x. Well, this right here, that's a restriction. X cannot equal 0. And over here, if we solve for x, we get plus minus 0, which is the same as just x equals 0. So as long as we didn't get 0 as one of our answers, we're okay. So because neither of these numbers are 0, both answers will work. So when it comes to negative exponents, we do it in a similar way to what we did in the last unit for simplifying. We're going to move the negative exponents to the denominator, and then we're going to look for the LCD that we can multiply by, so that way we can get rid of our fractions when solving. Okay, I want to do one more just to make sure we're okay. And this one is going to be similar to a test question, so I am going to ask you to star it or highlight it, so that way you have it down as one to go back and study. So this one, number 3, we have 1 over x plus 2 in parentheses squared plus 1 over x plus 2, and then a minus 6 equals 0. So this one doesn't have any negative exponents, so we can go ahead and just start with our LCD. And before we get an LCD, remember you have to make sure your denominators are factored so that we get the LCD correctly. So LCD, I have an x plus 2 squared, an x plus 2, and this has a 1, and even 0 has a 1. So just like in the one before, if the base is the same, you just take the higher exponent. So here they both have the base of x plus 2. This has an exponent of 1, because we only have one of them. This is 2. So the higher exponent is the one that I'm going to take, so x plus 2 squared. And I'm going to multiply that LCD to each term. Including that 0 over here. So after we multiply, in the first term here, the x squared is going to go away completely, meaning we'll have just the 1. And one of the things that's common about this one is because we think it all cancels, we put 0, but when something cancels or you have the same number on top and bottom, it's a 1, it's not 0. So make sure you put the 1 placeholder. On the second one, we'll have one of the x squareds cancel. Again, we're multiplying by 1, so we'll have just the x plus 2 that didn't cancel in that second term. For our third one, nothing canceled, so we'll have x plus 2 in parentheses squared times 6. And over here, anything times 0 is 0, so we don't even have to worry about actually foiling that out. So now I've gotten rid of the denominators. I'm going to go ahead and simplify so I can combine like terms. So when I simplify, I am going to need to FOIL this out, which we want to remember x plus 2 times x plus 2 is what x plus 2 squared equals. We don't just make it x squared plus 4. That's not a valid numerical equivalence. We have to actually write it out twice and FOIL it to make sure we get the correct next step. So over here I have x, and I'm going to add 1 plus 2 to get 3. Now for this one, I'm going to FOIL these two together. So that'll give me x squared plus 4x plus 4. And I still need to distribute that -6, and I'm going to remember to distribute the negative with it. And when we distribute that negative, it's going to change all the signs on the inside. So -6x squared, -24x, -24 equals 0. Now I can combine like terms. So -6x squared, 1x minus 24x will give me -23x, and 3 minus 24 will give me -21. And I have it equal to 0. So now we're at a point where we can actually factor and solve. And so I have a personal preference where I don't like negative leading coefficients. So I'm going to factor out the negative, and that's going to change my signs to positive on the inside. And all that does for me is it just makes it a little bit easier, because now I have one less, I have a negative I don't need to worry about. So I can do my double bubble. So let's see, two things that multiply to 6x. Let's try 2x and 3x. And now 21, that I have 7 and 3 and 1 and 21. So if I put the 7 here and the 3 here and test my outer and inner, these are both going to be pluses because I need it to multiply to a positive and add to a positive. 14 plus 9. So 14 plus 9 is in fact 23. So I have my correct factoring. So I'm going to take each factor and set it equal to 0. And this is where you need to remember the negative is a constant. It doesn't have a variable, so we don't have to set it equal to 0. We only set the expressions that contain letters, or that contain our variable, equal to 0. So here I'll get 3 halves, and over here I'll get -7/3. But before we can officially say that's our answer, we have to check our restrictions. So we look at our denominators. We have x plus 2 and x plus 2 squared. So here we'll get x cannot equal -2. And then over here we can square root both sides. The square root of 0 is just 0. So we also get x is -2. So pretty much x cannot equal -2. Well, we didn't get -2 as a possible answer, so that means both of our answers could be correct. So again, this one, star it or highlight it or something, because you do have a test question, that is very similar to this one.